Hi everyone. So let's continue the process of dissecting some of the technical things in order to develop uh, another version of Z, but that has finitely many elements, or breaking Z parts into uh, disconnected parts by using the remainders. So anyway, so last time we developed the notion of congruences. So let's use that notion to see a couple of useful things we can figure about it. So what I like about mathematics is kind of like it's a big puzzle, so to speak, and there is a lot of there is a lot of disconnected parts, and like I think mathematics really improve like a person's entire nervous system if it's done properly. Yeah, so I'll talk about that maybe in the future or at some point. So yeah, so anyways, let's continue where we left off. So we have the following definition. Let A and N be integers with N is greater than 0. The congruence class of A modulo N denoted as is the set of all those integers that are congruent to A modulo N, that are congruent. So we can just, like, we defined what a congruence is. Sometimes in mathematics it's useful to define a set of things where it satisfies a certain property and analyze that set as, like, when you're collecting things, there might be algebraic data that you can probe into. There might be geometric data that you probe into, etc., etc., etc. So it's good to packet things into boxes, so to speak. To A modulo N. So that is, you could write the congruence class of A, and that is defined as a set of those B in Z such that B is congruent to A mod N. So what does this mean? It means that it is those B inside of Z such that N divides B minus A, so such that there exists a K inside of Z such that B minus A is N times K, or in other words, it is those B inside of Z such that you can write B as A plus NK. So it is those B equal to, or you could write it more as a shortcut as A plus NK, where K belongs to Z. Yeah. So, for instance, in congruence. Modulo 5. We have the class of 9 is equal to 9 plus 5 times k, where k belongs to z. So that is equal to 9 plus or minus 5, 9 plus or minus 10, etc. Okay, perfect. So as you see here, that the class of A is, you have shifted A by some multiples of n. So you can break everything apart and you find that this is the same thing as collapsing all of those remainders that are shared between A. I'll talk about that in more details in the next few videos as we analyze this process very deeply. Okay, so let's see. So let's see the following result. So we have the following theorem. Theorem 2.3 that tells you that A is congruent to C mod n if and only if the class of A is equal to the class of C. So whenever two things are congruent mod n, then that means that they give rise to the same set. So that's the important distinction here, is that the equivalence class of an element is actually a set. So it's a set of those things that are congruent to that element. So what's interesting is that if they are congruent to each other as elements, then they give rise to a set where that set is, we defined it earlier, and that's those sets are equal. So as I've mentioned, it's important to in mathematics to create things as tools, and those tools could capture the bigger picture and give us understanding of how things actually operate. So I'll make this video short, and I'll analyze those things deeply in the next one. And see you guys. Bye.